Okay, we're going to look at using prime factors to find the highest common factor and lowest common multiple using a Venn diagram. So we're looking for the highest common factor and lowest common multiple of 15 and 35. I'm going to break 15 into a product of its prime factors. 15 is equal to 3 times 5. Both numbers are prime numbers, so we're going to circle them, and that's written as a product of its prime factors. 15 is equal to 3 times 5. Do exactly the same thing with 35, in that that's 5 times 7. Circle them both because they're prime numbers. So we now know that 35, written as a product of its prime factors, is 5 times 7. So we know that 15 is equal to 3 times 5 and 35 is equal to 5 times 7. We're going to use a Venn diagram, put the factors of 15 on the left hand side, factors of 35 on the right hand side. In the centre we're going to have the overlapping region, prime factors of both 15 and 35. So if we line 15 and 35's prime factors up, we can see that our common factor in this case is 5. So 5 is going to go as a prime factor in the middle, and 3 times 5 is 15, and 5 times 7 is 35. Now our highest common factor this time, the one that's common in the middle, is equal to 5 on its own. Our lowest common multiple in this instance is equal to all the numbers multiplied together, 3 times 5 times 7. Now we can see that 3 times 5 times 7 can be written as 3 times all of this multiplied together is 35. So we can write 3 times 35, and we can also write that as, we know that these two numbers multiplied together are 15, so it's 15, the same as 15 times 7. Now all three of those answers give us 105. 105 is the lowest common multiple of 15 and 35, and the highest common factor is 5. We'll do exactly the same now to find the lowest common multiple and the highest common factor of 24 and 60. So we're going to break 24 into a product of its prime factors, 2 and 12, circle the 2, its prime number, break the 12 into 2 and 6, circle the 2, it's a prime number, break the 6 into 2 and 3, circle them both, they're both primes. So we then know that 24 is equal to 2 times 2 times 3, 2 times 2 times 2 times 3, the product of its prime factors. We're going to break 60 up into the product of its prime factors, 2 and 30, circle the 2, 2 and 15, circle the 2, as a prime number, 3 and 5, 3 times 5 is equal to 15. So 60, written as a product of its prime factors, is equal to 2 times 2 times 3 times 5. So we know 24, written as a product of its prime factors, 2 times 2 times 2 times 3, 60 is 2 times 2 times 3 times 5. So we're going to position factors of 24, the left hand side, prime factors of 60 on the right hand side, the overlapping region, prime factors of both 24 and 60. So we can see now if we overlap them there that the prime factors of both, there's a 2, there's another 2, and we've got a 3 and a 3. So in the overlapping region we're going to have 1, 2 2s and a 3, and we know those multiplied together, 2 2s and a 3 multiplied by another 2 here give us 24, 2 2s and a 3 multiplied by 5 give us 60. So our highest common factor are the numbers in the middle multiplied together. So our highest common factor in this case is 2 times 2 times 3. 2 times 2 is 4 times by 3 is equal to 12. Our highest common factor, the biggest number that divides into 24 and into 60. Our lowest common multiple is all of these numbers multiplied together. So we've got 2 times 2 times 2 times 3 times 5. Now there's another way that we can write that, because we know that 2 times 2 times 3 is 12. So 2 times 12 times 5, okay, we know that's equal to 120. We can also say all these numbers here multiplied together are 60, so we can write it as 2 times 60, which is equal to 120, and we can also say it's 5 multiplied by 24. So our lowest common multiple is 120.